friends, today we are going to do something different. Well, you must be finding the formulas very confusing and difficult to by heart them. But then, if you understand them correctly, then you don't have to by heart them at all, right? We concentrate on making well-formed minds and not well-filled minds. So, without waiting any further, let's start the session. Now, since this session is based on formula, which part of circles do you actually think need a formula to find? Well, here we have a chart which covers all the parts of circles. So, the first thing we see is a radius. And radius is the most important part in our circle. Well, the next thing we see is a diameter, a chord, secant. All these things do not need a formula to find. Well, the next thing we see is a circumference. Well, yes, now this looks like that this might need a formula to find. So, we'll keep circumference aside. Next is tangent. So, what do you think? Will we need a formula to find tangent? No, right? Because by its definition, tangent is just a line which touches at one and only one point of a circle. Next is arc. So, do you think arc will require a formula? Well, arc is a part of circumference, right? Now, since we require a formula to find circumference, we'll obviously require a formula to find arc. And the next two things remaining are sector and a segment. Yes, both these things also require a formula. In this chart, there is one more very important thing which is not there. Can you figure it out? What are we talking about? Yes, we are talking about the area of a circle. So, these are the certain parts of a circle which requires a formula. So, here we start with the circumference. The circumference formula is C is equal to 2 pi r. But if you remember the video, then you will surely know from where the pi has come into the formula. The mathematicians found that the ratio of circumference and the diameter of a circle always came to a constant, that was 3.14 so on. And they named this constant as pi. So, now we can say that whenever we have r, that is radius, and pi, we can surely say that the formula is related to a circle or any curved object. Now, the next formula is for the area of the circle. Now, as we said before, we will surely have pi and r in the formula. Now, do you remember that how using the circumference formula, we derived the formula for the area of a circle? So, what we did, we converted the circle into a rectangle with the sides as pi r, and the area came as pi r square. So, these are the formulas for area and circumference of the circle. And if you're still getting confused, then just remember that circumference is just length, and hence it will always have only r, which means it is one-dimensional. And area is the space covered by the circle, which is two-dimensional, and so it will always be r squared. The next two formulas are very simple and based on these two formulas only. And now, if you have to find a fraction of circumference or a fraction of area, then how will you find it? So, we will need the formula for circumference and area. But we need a fraction. So, what the fraction will be here? Or how will we find the fraction? Now, here we can see that some measure of the angle is given, which covers the circumference and area, correct? Now, the area or the circumference that we need to find solely depends on this angle. How? Now, if we increase the angle, the area and the length of the circumference covered by it also increases. And if we reduce the angle, then we can see that the area and the circumference has also reduced. But in order to form a fraction, we need the whole part also. And here, the whole is the circle. And the angle is a part of the circle, right? And the whole circle is nothing but 360 degrees, correct? So here we found out that our fraction will be 360 by theta, correct? Well, this looks something wrong because theta is a part of 360 degrees, which is a circle, correct? Theta has to be always in numerator, so it will be theta by 360. Now this can be a very common mistake, so just make sure you don't do it. So now here we have a fraction, that is theta by 360. Now we just need to multiply this fraction with the circumference to find the length of the circumference, which is covered by theta, and the same fraction we will multiply with the area to find the area covered by the theta. Now in here we call these as length of an arc and area of a sector. Now here we are done with 4 formulas in less than 6 minutes. I believe that after this you don't have to mug up these formulae ever again. Now one last formula as a departing gift, the formula to find the area of the segment, and this is also very simple. Now here we can see that we need to find the desired area by subtracting the area of the triangle from the area of the sector. And by now, I believe that you guys know both formulae. Now when we look at the last formula, it is really not a formula, but we just combine 2 formulae, right? Now when we have such different combination of shapes, then we can use such differently combined formulae. Let's have a look at certain examples. I'll just give you an overview and you can solve them by yourselves. Let's see the first one. Now here we need to find the shaded region. We have 2 basic shapes, a square and a sector. Now the desired area that we need to find can be found by subtracting the area of the sector from the area of the square. Right, so these are the various places where you will get different combination of shapes and you will have to apply different formulas to obtain the answer. So let's see the next question. That is a little tricky one. So we need to calculate the area of this track here. Now we cannot see or we cannot identify any basic shape like a square or a rectangle or a circle, right? Now what we do here is we divide the track into basic shapes. Now we can divide it into 2 rectangles and 2 semicircles, correct? Now we can use the area of rectangle for these. So it will be twice into area of rectangle. And now we need to find the area of this curved surface. So for that, can you think of any idea? Yes, in here we will subtract the area of smaller semicircle from the bigger one, and that will give us the area covered by the curve, right? Now we have all the areas we need and we just have to add them. So the area of the running track will be twice the area of the rectangles plus twice the area of the curved surface. Well, let's see another one. So here also we need to find the area of the shaded region. So what can we do in here? Now other than a square, it is difficult to see any basic shape, correct? But if you notice correctly, we can see that there are 2 sectors which are infused together to form this shape, right? And we have to find the shaded region. Now what we can do is, we can get the area of the sector, and when we subtract that area from the square, we get the area of this region. Now we have 2 such kind of regions. Now you know where I'm going with this. Now we subtract these unshaded regions from the area of the square to get the desired shaded region. Now these are the certain examples. You can get variety of such combinations of shapes. Well, one of the most important and the basic tip here is that you need to try to identify the basic shapes like a square, a rectangle, a triangle, a circle, or maybe various parts of circle. Well, if you need a help in the formulas for surface area and volumes, do watch our video. So that's all for this session. Have a great day. Thank you and keep watching and keep learning.